Okay, welcome to 5.5, logarithms, properties. What we're doing here is understanding that when you multiply in a logarithm, it really means add, or you can put them together. So you can go back and forth between logarithms. And if you divide, it means subtraction. Again, you can go back and forth between the two. And if you raise a base to an exponent, the exponent goes out in front. Okay, let's get at it. Okay, so express in terms of logarithms, meaning just expand it. That's all you're doing here. So we have a multiplication. So 1a is log base 4 of x plus log base 4 of z. And then part B, you have a division. So it's log base 4 of y minus log base 4 of x. Okay, first one, top one minus the bottom one. And C, log base 4. You have a couple things here. That's going to be z to the 1/3. So we're going to put 1/3 as the exponent. It goes out in front of your logarithm, and you just put z there. All right, going on. Okay, so we've got a bunch of stuff here. So let's just start and do a bunch of different things. Let's put log of a of x cubed times w, okay, minus log of a of y squared z to the 4th. So the division means, or the fraction means, subtraction. Okay, so now we expand the first part here. We have an x cubed, so that's going to be log, 3 log of base a of x, and the multiplication means plus log base a of w. All right, now minus, now we're subtracting this whole group. So we have y squared, so that'd be 2 log base a of y. Multiplication means plus, and we have an exponent here, so 4 log base a of z. All right, now you can leave it like this, but really it should be expanded with no parentheses. Minus 2 log base a of y minus 4 log base a of z. Okay, again, same thing. Try to do these on your own, best you can. Oops. So I'm changing the radicals to exponents. So the answer should be 1/3 log z minus 1/2 log x minus, not x, I'm sorry. Let's take that off of there. The log of x, and that would be plus, except you have a minus sign here, you got to distribute through, so it'd be minus 1/2 log y. And that would be your final answer. Okay, let's just simplify this. X to the 7th over y to the 5th z, all to the 1/4. All right, so first of all, let's put the 1/4 out in front of the natural log. And then we're going to have to simplify this. So the 1/4 is first. And then we have 7 natural log of x. Subtraction is the division symbol there. And then y to the 5th would be 5 natural log of y. And since it's minus the whole group, you got to subtract the next one, natural log of z. So if you distributed, but we're not going to do that. Let's not distribute. But if we did, it'd be 7/4 natural log of x minus 5/4 natural log of y minus 1/4 natural log of z. Okay. 9a. Now we're going to put these together. So log base 3 of x times 5y. All right, so that answer would be log base 3 of 5xy. Okay, now b, this is a subtraction, so it's log base 3 of 2z over x. And that's the final answer. And c, we have a number out in front, so that's log base 3 of y to the 1/5, which is the 5th root of y to the 1st. moving on. Okay, so we have log base a of x squared, and notice we have two minus signs here. If we factor out the minus sign, then that would be a plus sign in there if you factor the minus sign out, and the plus means multiplication. So inside here we have log base a of x minus 2 to the 1/3 times 2x plus 3 to the 5th power. All right, so that means your top is going to be x squared, and the bottom is going to be x minus 2. We'll do cubed root times 2x plus 3 to the 5th power. And that should be your answer. Okay, so here again you have two minus signs, so I'm going to factor those two. Let's simplify this. So that's log base 10 of x cubed y squared minus what? Well, we have log, and again you factor out the minus, that becomes a plus left inside. So that would be log of, x squared. This right here is y to the 1/3, but then you got to raise it to the 2nd power, so that's y to the 2/3. And the plus becomes multiplication when you contract everything under one logarithm. And that's, not log. That'd be x cubed over y cubed. So we got to put all that together. All right. So inside here we get log of x to the 5th and 2/3 over y to the 3rd. That's y in the numerator of 2/3 minus 3 over 1. So get a common denominator, and that's negative 7/3, or positive 7/3 in the denominator. Okay, so what's our final answer? We have log, that's not final I guess, x cubed y squared. The minus signs mean division. X to the 5th over y to the 7/3. So we're going to take x cubed times y squared times the reciprocal of the bottom, y to the 7/3 over x to the 5th. 3 of those cancel with 3 of these, leaving 2. And 2 plus 7/3, get a common denominator. That's 13/3. So y to the 13/3 over x squared. Final answer should be the log of y to the 13/3 over x squared. Yes, that's tough, but just got to keep plugging away at them. 15. I'm not going to factor out a negative here. So what that means is this goes together as a multiplication, and we're going to divide by the last part. So natural log of y cubed times, take 1/3 to both of those. So 9 times 1/3 is going to be x cubed, and 6 times 1/3 is 2. And then you're going to divide it by y to the 5th. Okay, so now just simplify. Natural log. We have x cubed. Y squared and y cubed is y to the 5th over y to the 5th. Those cancel out. So that's the final answer. All right, 17. Okay, so we're solving here now. What do we do with solving? All right, so if you have all the logarithms here, so log base 6 of 2x minus 3 is equal to log base 6 of 24 divided by 3, or 8. So if the logarithms are the same, then these things are the same. So add 3 and divide off the 2. All right. Okay, logarithms are the same. Put that as an exponent. And that is an exponent. So that means x squared equals 5 cubed. So x squared equals 125. Take the square root. That's the square root of 25 times 5, or 5 square root of 5. All right, cool. Combine these. So log of x over x plus 1 has to be equal to the log of 4 cubed. So the bases are the same, so x over x plus 1 has to equal 4 cubed. So x equals, we're going to cross multiply there, 64x plus 64. That's a 1 there. And so subtract x, and you get 63x plus 64. Subtract 64, divide off the 63, and x equals negative 64 over 63. But can x be a negative value? Can you take the logarithm of a negative? If you remember graphing logarithms from our notes, logarithms go like this unless they've shifted, and these have not shifted here. So the logarithm, there are no x values that are negative here. So this is a no solution, only because we know we're not going to use that, okay? All right, so again, that's the natural log of negative 4 minus x times 3, and 2 minus x. So we're going to distribute, take away the natural log. Negative 12 minus 3x equals 2 minus x. Again, you have the same logarithms. So add x to the left, add 12 to the right, and x is negative 7. Okay, let's combine these. Log base 2 of x plus 7 times x equals 3. So now I convert this out of logarithms. The base raised to the answer equals this. So this part is x squared plus 7x, and 2 to the third goes there. So x squared plus 7x, 2 to the third is 8. Let's move it over here, so subtract 8. And now you can solve that. X plus 8, x minus 1. So my answer is either negative 8 or positive 1. And again, negative 8 isn't going to work. The reason I think you have a negative on the last problem is because the minus sign is in front of the x, which changes all that stuff to positives. All right, let's move on. So that you shouldn't use negative 8. All right, now see we have negatives in front of the x's here, which all of that changes all the negative signs. So x's can be negatives on these. So let's just put this together. Log base 2, it's multiplication, so negative x, you're going to distribute that through the 2 minus x equals 3. So since there's now a logarithm on both sides, we can change all this. That's negative 2x plus x squared, and that's 2 cubed, or 8. So we have x squared minus 2x. Let's move the 8 over. And now let's factor. And we get x minus 4x plus 2. And so x equals 4, or negative 2. And in this case, positive 4 is not going to work. It's because of these minus signs that are in front of your x's. So negative 2 is actually going to be the answer. 29. Again, let's just combine these and raise the base 3 to the first power. Sorry, x plus 3 times x plus 5. And 3 to the first is just going to be 3. So FOIL everything. X squared plus 8x plus 15 equals 3. Subtract the 3. And x plus 6, x plus 2 equals 0. So either x is negative 6 or negative 2. Now, will that actually work? Notice the x's are positives here, but you're inside this parentheses. So you can't take the logarithm of a negative value. If x is negative 6, that makes the first one not possible, and the second one. Okay, so that can't work. But if I plug negative 2 in the parentheses, that's going to be log base 3. Let me use a line here. Log base 3 of negative 2 plus 3 is positive 1. And negative 2 plus 5 over here is positive 3. So you're taking the logarithms of positives. So the answer has to be negative 2, not negative 6. All right, now the big problem here. The 1 doesn't have a logarithm. So let's add that logarithm to the left. And then you see you have an addition, which means multiplication. So log of x plus 3 times x minus 2 equals 1. This is base 10, so 10 to the first equals all of that. So all of this is x squared plus x minus 6 equals 10 to the first. So subtract 10. X squared plus x minus 16 equals 0. Okay, so now factors of 16 that give you 1x. Well, there isn't one, so now you have to use the quadratic formula. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So negative 1 plus or minus negative, and a negative, this will be a positive, so that's 1 plus 4 times 16 is 64, plus 1 is 65, all over 2, and that would be your two possible answers. But if we take negative 1 minus the square root of 6, let's say it's the square root of 64, which would be 8. So if we take negative 1 minus 8, that's negative 9 over 2, which is negative 4.5. All right, if you plug negative 4.5 in here, you're going to get the logarithm of a negative answer. So it can't be a minus here. So it would have to be a negative 1 plus 8 point something, which would be positive. So the negative doesn't work on this one. So it's negative 1 plus the square root of 65 over 2. Okay, we're going to subtract, which means divide. 20x over x minus 5 equals 3. This is base 10, so what do we have here? We have 20x times x, divided by x minus 5 equals 10 cubed is 1,000. Okay, let's go ahead and distribute. Cross multiply, so 20x equals 1,000x minus 5,000. So we'll subtract 20x and add 5,000 on the left. And that's 980x. Divide off 980. And x equals whatever this thing is. If we divide it by something, I don't know. I'm going to take it by 10. That's down to 500 over 98. Divided by 2, that's 250 over 49. And 250 is not divisible by 7. So that should be the answer. Okay, it's the same thing as the last few problems, except instead of a log of some base, it's the natural log. So subtraction, let's go ahead and add it, which means you're going to multiply when you combine them. And base e, so that's going to be e to the first equals x squared plus 2x. Okay, so 0 equals, not e, x squared plus 2x minus e. Okay, all right, so we can't factor that, so we got to use the quadratic formula. Whoa. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So negative 2 plus or minus 4 times, 4, and the minus sign and the negative make a plus. That's 4e over 2. I'm going to factor a 4 out of that 1 plus e inside there, which is the same thing as saying the square root of 4 times the square root of 1 plus e. You can change out your multiplication. The square root of 4 is 2. So what we have here is negative 2 plus or minus 2 square root of 1 plus e all over 2. And all the 2's reduce, so negative 1 and it's plus or minus 1. The 2 is divisible into both of those. That should be our answer, but now it's plus or minus. So E is the 2.712. You add 1 to it, take the square, it will be a positive 1.93. So if you subtract, it'll give you a negative, and you can't take the natural log of a negative. So the answer really should be negative 1 plus the square root of 1 plus E. Okay, number 37. Whole lot of different things. They all have the same base. And what's important, you have to look at something like this right here. So we need to keep on simplifying things that we can see. So that one at the end, and then this one here as well. So I'm just going to do one little thing at a time each step of the way here. And this is log base 3 of 3 cubed. 3 cubed is 27. Okay, and we still have this log of x minus 4, and then you have the 5 and the 5 there. That means this is just whatever that position is, 1. And so now I'm going to help you understand that's a 3, okay? Whatever the exponent is, that's going to be the answer. And I'm going to move this to the other side. So I have log base 3 of x minus 2 plus log base 3 of x minus 4. Excuse me. And that's equal to 3 and a minus 1, which is going to give you 2 on the right side. Now on the left side, the plus sign means multiplication. So log base 3 of x minus 2 and x minus 4. Multiply that together. You get log base 3 of x squared minus 6x plus 8. And now we convert it to exponential. So that's x squared minus 6x plus 8 is 3 squared, which is 9. So subtract 9 to the left, and it's x squared minus 6x minus 1 equals 0. Now we use the quadratic formula. X equals minus b, plus or minus square root of b squared, minus 4 times a times c, all over 2 times a. So 6 plus or minus. The minus a negative 4 would be plus 4 would be 40 over 2. And 40, square root of 40, is the same thing as 4 and 10. That's 2 square root of 10. 10 breaks down to 2 and 5, but that doesn't help you. So this is going to be 6 plus or minus 2 square root of 10 over 2, and the 2 goes into both of those. So x is equal to 3 plus or minus the square root of 10. And the square root of 10 is 3 something, so 3 minus the square root of 10 is going to give you a negative. And we're not going to take the logarithms of negatives. So the real answer is 3 plus the square root of 10. Okay, so the log base 3 of 3x, if we break this apart, it's log base 3 of 3 plus log base 3 of x. Remember, when you add, you're multiplying. And whenever these are the same, it's the exponent. So this is going to be the log base 3 of x plus 1. So the plus 1 is outside of the function. So it's going to raise the log of x up 1 unit. So the log of x, the parent function, goes through here, looks like this. So our new function is going to move up 1, and it goes like that. So same graph, just bumped up 1 unit. Okay, so here, this is going to be log base 3 of x cubed. But all that really means is we need to look at this. That's stretching your graph by 3, vertically 3 units. Okay, so again, if you wanted to do it like this and do an XY chart until you understood, I mean, you still have your typical graph, okay, that goes like this, all right? But the 3 stretches it. It's still going to go through 1, 0. So when x is 1, we can think of it this way. 1 cubed is 1, and the log of any base of 1 is still going to be 0. So that's not going to change and then you can plug in a couple other points. If we made x 3, when x is 3, what do we get? So it's log base 3 of 3 to the third. So that's going to be 3. So when x is 3, y is 3. So this is the same type of function. It's just stretching up vertically. Okay, same thing with this thing. Log base 3 of x squared. So you just put the 2 out in front. It's the same thing. You're stretching it by 2. So again, the parent function goes through it, 1, 0. Okay, and again, it's the same thing if no matter what you do, when x is 1, the log of 1 is still 0 times 2 is still 0. But let's go ahead and put 3 in again. So it's log base 3 of 3 squared. Okay, so that's 2. When x is 3, we're at 2. So it just stretches it up a little bit less than the last problem. That's all you had to worry about it. Now what's over the top for this is that it's set up as x squared. So technically you could put negatives in there. And what that means is it's the exact same graph with all the negatives that go through and match it on the other side. So it's symmetrical. It's both the red and the blue graph there. But if the function is set up like this, then it's only positive values that you could put in. All right. Now, it's the same thing, except you can't have negatives in here because when you cube a negative, you still get a negative. So this is only going to be in the positive area. So you could still put the 3 out in front here. And you're still going to do, if you did an XY chart, when x is 1, you're still going to get 0 for y. And then times 3 is still 0. And since the base is 2, let's put 2 in for x. So that's log base 2 of 2 to the third, which that answer is going to be 3. So if we graph this, okay, 1, 0 is our parent function. And we graph the new one, still goes through 1, 0. But when x is 2, we're up at 3. All right, so it stretches it vertically. That's all. All right, but since it's like that as far as the cubed function is concerned, then it just stretches it up. It doesn't change anything as far as allowing you to have negatives. You cannot have negatives. All right, moving on. Now we have, think of it like this, log base 2 of x to the 1/2, or it's 1/2 log base 2 of x. So it's the same function as we had before, except this is going to make it shorter. You're going to shrink it. So if we put just a couple problems in here, a couple numbers, all right, our parent function here, and again, no matter what we do, when x is 0, we're going to get, when x is 1, we're going to get 0. Now, let's plug in 2 for x, and it's log base 2 of 2 to the 1/2. Okay, so that answer is 1/2. So when x is 2, we're at 1/2 right there. So it really shrinks it, or brings it down, if you want to think of it that way. All right. So moving on to the last problem. So what do we have here? We need to rewrite it. Now remember, x can't be 0, which we already knew that. We're going to write this as x to the -1, which is -1 times the log of 3 of x. So if we're going to look at this one, you can make an XY chart, and still, when x is 1, we still get 0. So you got to be careful of this part, because now you need to understand what the graph of this looks like. So we're still at 1, 0. This is our parent function here. Now, parent function means that's just the normal log of x. But this is not log of x, it's log of 1 over x. Okay, so just think of it this way. If we convert this to an exponential, it's 3 to the y value equals 1 over x. All right, So it makes it a little strange. It's an exponential function, and it's different than what we're used to. So let's plug in 3. So log base 3 of 3 to the negative 1, that's negative 1. So when we're at 3, x is negative 1. We're down here. So what has happened is that's a vertical reflection. So it goes like this. All right? And that's what you should have for an answer. So when you look at it in different forms, it'll give you an easier way of understanding what it looks like. All right, good job.